Okay, first of all, general safety. What are the two things that we absolutely have to wear in shop?
Safety glasses.
Okay, first of all, safety glasses. We always have to wear our safety glasses. What's the other thing? Shoes. Okay, we always have to have closed-toed shoes on. What can we not wear in the lab? Okay, loose clothing or jewelry. Why? Okay, it can get caught in the machines. That's the biggest concern in here. We've got a lot of rotating equipment. We don't want someone's necklace to get caught in rotating equipment, or loose hoodie strings, or even baggy clothing. All right? So we've got what we need to wear, we've got what we should not wear. Now, general electrical safety. We're going to be using some power equipment in here for your first little project. Some of those require electricity, so we got to have a general background with electricity. Now, a little review from your past science classes. There's conductors and there's insulators. Can you tell me what materials would be good conductors?
Water.
Okay, I'm hearing a lot of metals, right?
Gold.
So I'm just going to generalize and say metals. Out of those metals, what'd you say? Copper.
Gold.
Copper is one of the best conductors. Gold's even better, isn't it?
Gold is the best.
Right. Why don't we use gold?
Because it's too expensive.
It's really expensive. You guys remember a year ago, 2 years ago, when copper was very expensive? It's not as bad as it was, but it's still pretty bad. Copper was so expensive. I remember being in Las Vegas, and my buddy that lived there was saying, yeah, people go out at night and they'll pull wire from all the street lights. They'll go and salvage it for cash. So it's a type of precious metal. It's getting to a point where you're going to have to find an alternate form of conductor to use in all of our wiring. It's a very good conductor, but like Shane said, gold is even better. How many of you have stereo equipment with gold connections? Right? That makes the best connections. They don't use very much of it, do they? They don't have an entire wire made of gold. That'd be a fortune. Right? So just the conductors use gold.
They like just put gold plate on it.
Yeah. That way it's cheaper, right? So they try to make it as cheap as possible. Copper is one of those metals where it's relatively cheap yet, but it's a very good conductor. There's also steel, aluminum, but what?
Silver.
Silver. Are any of those better conductors?
Yes.
Silver. But aluminum, is that a better conductor than copper?
No.
No. Okay, aluminum's pretty available, really. But no. So we say that metals make good conductors. Okay? What's another good conductor?
Water.
Water. One of our biggest concerns in here is water. How much of the human body is made of water?
60%.
How much? 60? I've been hearing different things all day. 50, 60, 70, 80%. Point is, the majority of the human body is made of water, right? So that means the human body is a good conductor of electricity. We've got to protect ourselves. That's another reason we wear shoes, hopefully rubber soles. Ever see a construction worker wearing flip-flops? Probably not, right? One, they're protecting their feet. Two, if they happen to be standing in a puddle or something, that current isn't going to go up through their body, hopefully. That's why they try to wear rubber-soled shoes.
Unless they have like a nail sticking out of it.
Yeah. So, there's our two good conductors of electricity, metals and water. All right. What's an insulator?
Rubber.
Rubber. It's probably the best insulator. Am I going to find rubber around all these wires? It's not necessarily all rubber, is it?
Plastic.
Okay, there's another one. Plastic. So rubber and plastics are our two biggest insulators. A lot of times you'll find wire that's not as flexible. That's probably telling you that there's some kind of rigid plastic around it. So you see that all wires have some kind of coating around it, which is the insulator. So that means the wire is our conductor. So we know what conductors are, we know what insulators are. Now we got to think about the electrical system. Part of that electrical system is maybe a cord. You take a power tool, you got to plug it in, right? Let's take a look at this one. It used to have 3 prongs. See that one missing? Do you know what that one missing is called?
The ground.
The ground prong. Do you know what the ground prong is for?
Prevents electrical shock.
Yes. It takes stray currents, it flows it through that ground prong into your electrical system, which at some point in the whole electrical system, or points, could be several, they'll take a wire, physically run it outside, and they'll tie it onto a big steel rod. It's usually got a bunch of little holes drilled through it. They'll drive that into the ground. So that's where it comes from. Stray currents are going to go through that little prong through your electrical system, out, down that steel spike in the ground, and release into the ground safely. So that's where the ground comes from. What else, what other problems could I find with electrical cords? What tells me that they're bad? Don't use them. Okay, frayed. Okay, we could have some exposed wires that are frayed, right? What else?
Cracks in the plastic and stuff after it dries up.
Right. Any problems with our insulator, whether it's cracked, sometimes it's sanded off. This cord is telling the insulator got sanded off. It's cracked, it's chipped, it's torn off. Point is, if we can see exposed wire, that's not good. What do you need to do if you find that?
Tell you and get rid of it.
Right.
Tape it.
Tell me. I'm not just going to tape it.
Electrical tape.
Still, what's going to happen when that electrical tape falls off?
You retape it.
That's the answer, I think.
What I'm going to do is I'm going to cut it at 2 clean spots, re-splice it, and then I'll put tape around it. That way if the tape does come off, it's still spliced, it's still got some kind of protective coating around it. Right? It's kind of doubling up on protection there.
That's not how Van Pay did it.
Yeah, let's not talk about that.
Van Pay just puts it
Yeah,
together.
I know. Back there, I've got sometimes 6 tools running off of the same circuit. Got a couple saws, a couple routers, maybe a sander, and a couple other machines. Last year this happened a few times. We had all 6 machines running at the same time. All of a sudden they all shut off. What happened?
Short.
Okay, see those 2 gray panels back there?
Yeah.
There's a bunch of circuit breakers in there. What's going to happen if the circuit is drawing too much current is that breaker is going to shut off. What that does is it prevents a fire. If I've got all 6 of those tools, each one's pulling its own current. It's trying to pull a lot of current through a small wire. I could fix that by putting a bigger wire through there with a bigger breaker, but it takes a lot of time and money to do that. Right? So that's why we have our breakers in there. And running too many tools, it's pulling too much current. Think of it this way. If you go and rub against a surface, what happens? Friction, right? It warms up. You can think the same thing when too much current is being drawn through a circuit. It's creating friction. It's only electrical kind of friction, and it warms up. Too much current going through a small wire, it's going to create heat, it's going to start a fire. We don't want that to happen. To prevent that, that's what the breakers are for. Once it senses that too much current is being drawn, it'll shut the circuit off. No more current can flow through it. It won't start a fire. We got circuit breakers. What's another device that can prevent fires?
Fire extinguisher.
Prevent the fire. Yeah, it's a fuse. Okay? Some of your houses may not have been updated yet. If not, you will find little fuses that get twisted into a socket. Fuses, are a disadvantage compared to breakers, because breakers can be used over and over again. All you do is flip the switch from on to off. Fuses, on the other hand, have a little chunk of wire on the inside. When that wire burns up, then the fuse separates the circuit, it stops current from flowing. So it's shot. You got to get a whole new one. Anyone put together their Christmas lights? You put together maybe 6, 8 strands, and they all go out. Did you play around with the ones that have a little glass tube fuse built into the plug? Right? Most of the time, that little fuse breaks, right? So you can just take that little fuse and pop it in. So there's a couple different kinds of fuses. So we got fuses and breakers. Both of those will prevent fire. I think those are on your sheet. Write in these answers as they go. Okay, I got all the electrical stuff pretty much covered here. What do you guys need to do? We're going to be using a lot of sharp tools in here. We've got blades, we've got bits. We're going to be talking about some sanding equipment too. Do you think it's safer to have an extremely sharp blade or a dull blade? Extremely sharp is better. Think of it this way. If I'm cutting a board on the table saw and I've got a really sharp blade, is that going to cut easy or difficult?
Easy.
Pretty easy, right? It should cut like butter. Hot knife through butter. Now, if I have a dull blade,
It's going to be a pain in the butt. You're going to try too hard and something's going to go wrong.
exactly. Okay, if it's dull, I'm going to be putting too much force on that cut. It's not going to want to cut. That's when accidents happen. So we want to make sure everything's sharp. That's my responsibility. You guys really don't need to look for that. What you do need to look for is the condition of the blades. Let's take this one for example. If I go and turn on a machine and it doesn't sound smooth, it's probably because something like this happened. This came off the panel saw back here. Is that supposed to be an oval? No. If you look at this, it looks better on the back side, you can see how it's kind of burned. It got really hot, got deformed. That was because the arbor nut was not on there very tight. The blade was loose. So when I turned it on, it sounded wrong. You can tell when a machine sounds wrong. So, the blade got loose and it deformed the little arbor hole. So we have to replace this one. More commonly, what you guys are going to find is something like this. As I turn the blade around, what I'm looking for is a couple things. What do you guys see?
I'm missing one.
Yeah, right here. There's a missing tooth. So that's not good. We need to replace that. What's a little more minor than that is chips. These are carbide tip blades, which means they're made of an industrial type diamond. They're very brittle. Anything that's very, very hard is also very, very brittle. So what I don't want to see is someone taking a blade, most of the time it happens on this table saw, because you guys are changing the blades all the time. You don't want to take a carbide tip blade and set it on a metal surface. Instead, put it on a piece of wood, piece of plastic, something else. Okay? I never want to see these on a metal surface. They chip. When they chip, then we have to replace them. So what you guys are looking for are chips, cracks, any kind of damaged bit. Okay, same thing goes for drill bits. What happens if this thing is cracked? I go to drill in, what's going to happen to this?
It's going to snap.
It's going to snap off, right?
Flying shoot.
It could go flying, it could stay stuck in the board, who knows? Okay, so always check your blades and bits. The other thing is the sanding equipment. I have a belt sander here. This belt is in relatively good condition. What you need to look out for is frays. On the edges here, it'll start fraying when it gets worn. On the disc sander and spindle sander back there, they'll actually start tearing and cracking. That's what you're looking for. If that happens, you just need to replace them. If I do have to replace anything, What should I do with any piece of power equipment before I make adjustments?
Unplug, shut off.
Unplug it, shut it off. Okay? Mostly with portable power tools like sanders, routers, whenever I'm changing a bit or belt, I need to unplug it if I'm making any kind of adjustment. This bit right here, this drill bit, this is the most common type of bit that we're going to use. This is called a twist drill bit. I've got large ones, I've got small ones, and everything in between. These bits can drill through anything that's not brittle. Can it drill through wood?
Yeah.
Yes. Plastics?
Yeah.
Yeah. What do you think, metals?
Mm,
Yes, I'm going to show you that in a second here. You can drill through metals, it's not brittle material. What is brittle? Glass, ceramics, concrete, any of those. We can't use a twist drill bit. So the only things that can use a twist drill bit, metal, wood, and plastics. Okay? The most common type of drill bit that we have. So I'm going to show you guys how this twist drill bit can actually drill through metal. You guys are going to be using drills for your first little group project here. So I got to show you how the drill works. First of all, I'm going to need a bit in here. These have a keyless chuck. If I go and put this drill in forward, hold the bit in place, hold the chuck, I can tighten it up. So I can get the bit in here with the keyless chuck. Now, I need to set up the drill for a drill bit. I'm going to be drilling a hole. So this thing can either drill holes or drive screws. Any of you go mud bogging with your cars, trucks? No?
mud bog.
Yeah.
Do you mean
Go
four-wheeler?
purposely get your truck stuck and try to get it out?
Oh, four-wheeler.
Yeah. Okay, you know what I'm talking about. If you get your car stuck in the mud, snow, whatever, are you going to put it in first gear or second gear? First. And put it in first gear. That's going to give you the power to get that thing going. Okay, it's got first gear has the most power. We've got a first and second gear on the drill here, right up on top, little switch. First gear is good for driving in screws. Second gear is good for drilling holes. We need a higher speed, a more constant speed. Think of it just like your car. Second gear, you're going to be going faster. Next thing I want to do is set the clutch. This little thing here with all the numbers and a little picture of the drill bit is my clutch. If I got it set low, it's at 1 right now. The clutch is going to activate. It's not going to provide a lot of torque. That's good when you're driving in screws. If you got a soft material, you're going to want a lower number. Harder material, you're going to want a higher number. And it's going to engage with a higher torque. So eventually, once you get up to the drill bit, it's not going to stop at all. It's just going to keep going. Since I'm drilling a hole, I have it on the drill bit. It's the highest setting for my clutch. I've got it set to second gear. The other things, forward and reverse. If it's in reverse, it's not going to drill a hole. Twist drill bits are not set up that way. You're just going to start burning a little spot on your board. People do that every year. It's going to happen again. You're going to say, the bit's too dull. No, just put it in forward. All right? So you want it in forward. Last thing, you can adjust the speed of the drill just by pulling the trigger. The more you pull the trigger, the faster it goes. So if you're driving in a screw, you probably want to go slower. You don't just want to drive the screw in at the fastest speed. So I got it set in forward, got the clutch set to the drill bit, and it's in second gear. I'm going to drill a hole through this little chunk of metal here. I don't want to just drill straight over on top of my table. I have something called a backing board. Why am I putting a backing board under the metal? Yeah.
So you don't put it through the table?
So you don't put it through the table. We've got enough holes in these tables. We don't need more. So I always use a backing board. It's okay, this one's all full of holes. That's exactly what it's supposed to be used for. So I got my chunk of metal here. Drill's all set. I need to hold this thing in place or clamp it in place. My hand is staying at least 4 inches away from any sharp moving bit or cutter head or blade. Always. It's kind of a general rule we have in here. Always at least 4 inches. So I'm 4 inches away, I'm holding it tight, drill's all set. So yes, it will drill through metal. Okay, so there's our drill. Last thing I'm going to do here is sanding equipment. You guys already kind of saw our belt sander. We've got our belt sander. There are some finished palm sanders down here. And there's a couple pieces of sanding equipment in the back, which you're going to see in a little bit. The most amount of material you can remove with any sanding equipment is 1/8 of an inch. I'm going to be sanding down to this line. Can I start just sanding right now? You guys know measurement. Does that look like 1/8 of an inch or less? No, it looks like more, right? What can I do to get closer to that line?
Got it.
Got it. You guys aren't going to be using the large power saws just yet with this first project. You're going to be using hand saws. But I'm going to go use a power saw just to speed things up. So, 1/8 of an inch is the most amount of material that we can remove with any piece of sanding equipment. Okay? Why don't you guys put on your glasses and go right over here. Here I have the disc sander and spindle sander. The disc sander is used to sand outside curves. I want you to see which way the disc is spinning. Now what's going to happen if I sand on this side of the disc? What's going to happen is it's going to lift up. It's not safe. What I want to use is the downside of the disc to sand outside curves. So I'm going to turn this on and I can sand my curve using the downward side of the disc. So the disc sander does outside curves. The spindle sander does inside curves. There's a bunch of different sizes of spindles that I can use. They're all down here. We can change those up. So I'm going to use the spindle sander to sand my inside curve. Whatever machine we use, we always want to make sure that we don't remove the guard. The disc sander here has a guard. Each saw here has a guard. We don't want to remove any of those with any piece of equipment at any time.